Good afternoon, this is Schweitzer. We're going to do a specific heat practice quiz. And this has got some general energy transfer type things. Okay, so I have a energy label here and got a bunch of stuff here. Okay, so it says a 50-gram aluminum block gains 1500 joules of energy. Okay, the temperature block will increase by how many degrees? Okay, so let's do the math on this guy. Q equals mass times change in temperature times specific heat. Alright, the specific heat is, or the Q is 1500. It's in joules, so we're good. The mass is 50. Looking for change in temperature times heat, which is 0.9. Do the math on this guy. 1500 divided by 50 divided by 0.9 is 33 degrees. So this is 33 degrees Celsius. 33 degrees. True or false? Copper gains the same amount of energy and increases in temperature less than aluminum. Alright, so in this case, for number 2, would be the same amount of energy, so 1500, alright, equals mass times change in temperature times heat. So I want to find the mass, so it's going to be 1500, I'm going to find change in temperature, 1500 divided by, same mass, 50, but in this time it's going to be a 0.36 specific heat. And because this number is smaller, mathematically this would be bigger. So it's false. And the reason it is it has a lower specific heat. If you want to go with a non-mathematical answer, for the same amount of energy, it takes less energy for a given amount of energy, it takes less energy to raise a degree, and since it's the same amount of energy, it raises more degrees. How many calories per gram are in the sample? Okay, so this is just some conversion stuff involving tables. We do some this here, there. So how many calories per gram? Okay, calories per serving. So it's just a little factor label here. And there is 55 grams per serving. So I'm going to do that math right here. So I have 230 calories per serving. Dot line, get rid of serving and go to grams. 1 gram is equal to about 55, 1 serving is 55 grams, and therefore I'm getting 230 divided by 55 equals 4.18 calories per gram. 4.18 chemical, I should say commercial calories per 1 gram. This is number 3. Okay. Now let's look at number 4. How many joules of energy are released by 1 serving? By 1 serving. Okay, so number 4 we'll put right here. Just factor label. 230. Now this is a commercial calorie. Get rid of commercial calories and go to regular calories. And then get rid of calories and go to joules. 1 commercial calorie is 1,000 regular calories. 1 regular calorie is 4.18 joules. And punch your calculator. We're going to get 230 times 1,000 times 4.18 is 961,000 joules. That's a pretty large number, 961,000 joules. And a joule is pretty small, which is again why in Europe they would call it kilojoules. They'd use kilojoules instead of joules on food packaging. And finally, the last thing we have is number 5. If the amount of energy is used to warm 1 liter of water at 25, what would be the final temperature? Okay, so let's put that one. I got this guy's in my way here, but I'm going to put number 5 right here. Okay, so number 5 Okay, thermal energy. So 96,100. I'm only using 3 sig figs here. Joules equals, I'm using the specific heat formula, the mass of 1,000, 1 liter of water. So 1 liter of water is 1 kilogram, which equals 1,000 grams. So that's 1,000. I'm looking for the change in temperature, eventually figure out the final temperature, and then 4.18. Alright, so delta T in this case. So we got a little bit of, quite a bit of specific heat here stuff. So divide by 1,000, divided by 4.18, and get 230 degrees. Alright, so 230 degrees is my change, plus the 25 would mean that would be 280, 250, alright, equals 255 degrees Celsius, which of course is well above boiling. It could get above that temperature if it were in a pressure cooker of some sort, but it will be easily boiling. We'll stop there for today. Thank you.